Hello student, myself Digan Sakhiwala, I am your science sir. Today we will continue chapter number 4, the structure of atom. Dear student, today we are going to learn different model for the atom like Thomson model, J.J. Thomson model. We are going to learn about its limitation. Second thing, we are going to learn about the Rutherford model and Rutherford limitation. Afterwards we will learn about the Bohr's model. Okay, so we will start here. Chapter number 4, structure of the atom. The structure of atom. The discovery of two fundamental particles, electron and proton, inside the atom lead to the failure of this aspect of Dalton atomic theory. So dear student, we know that according to Dalton atomic theory, atom is the last part. Meaning of atom is also uncuttable or indivisible, means further it is not divided. But by the discovery of electron, J.J. Thomson carried out one experiment. From that he find out electron. And Goldstein discovered the proton, and from that we come to know that atom is divisible in the different particles. It was then considered necessary to know how electron and protons are arranged within the atom. So it is very necessary that in the atom how the electrons and proton and other subatomic parts are arranged. For that different model was proposed by the different scientists. Okay. J.J. Thomson was the first one who proposed the model for the structure of atom. So J.J. Thomson was the first scientist who proposed the model for the structure of atom. What he did, he take one vacuum tube, in that he take two plates, and that plate is connected with the positive and negative terminal of the battery, and he pass the current. When he pass the current, then he get one ray. Okay, he got the rays. And he checked the charge of the rays. He come to know that the charge of the rays are negatively charged. So he gave the name these particle as what? Electrons. Okay, whatever tube is there, that tube is called the cathode ray tube. Thomson model for an atom. Thomson proposed the model for an atom to that of a Christmas pudding. So you can consider the Christmas pudding. In that we consider the total part is positively charged, and whatever the materials are set on the pudding, that is what? A negatively charged electron. Or we can consider the watermelon. In that the red part is what? Positively charged, and seeds are what? Negatively charged. So this is what? A Thomson model for the atom. The electrons in the sphere of the positive charge were like the currants, dry fruit in the spherical Christmas pudding. So in the Christmas pudding, in that we can see that dry fruits are there, they are the negatively charged. Okay, and the other part are there, they are what? Positively charged. Same way we can consider what? Watermelon. In that red part are there, that is positively charged, and seeds are what? Negatively charged. So that was the model of J.J. Thomson. We can also think of watermelon. The positively charged in the atom is spread all over like the red edible part of the watermelon. Electrons are studied in the positively charged sphere like the seeds in the watermelon. So we can see that seeds are present in the watermelon, like that electrons are embedded in the what? Watermelon. And the red part is what? Positively charged. Thomson proposed that an atom consists of positively charged sphere and electrons are embedded in it. The negatively and positively charged are equally in magnitude, so atom whole electrically neutral. So second thing is most important, the negative and positive charge are equal in magnitude. So number of electron and protons are same, and because of that reason their charges are also same. So we can say that atom whole electrically neutral. Atom is electrically neutral because what? Number of electron, number of proton are equal, as well as their charges are also equal, so electrically neutral. All result of other scientists cannot be explained by the Thomson model. So many scientists did so many experiments, and from that what they come to know that J.J. Thomson model is not appropriate for all the type of experiment. Okay, so after that J.J. Thomson has one student, and his name is Rutherford. He carried out one experiment. He take very thin gold foil and he passed the alpha rays. Alpha rays are what? Alpha rays are made up of helium, and they are positively charged. So when he passed the alpha ray, most of the rays are passed. Now dear student, alpha rays are what? Positively charged, and nucleus in that protons are present, that is also positively charged. So we know that positive charge or repulsion occur. So he passed almost so many rays, from that one ray come back From that he concluded that in the atom one small part is present that is positively charged. He gave the name as what? Nucleus. From that they concluded that the proton is present in the nucleus and electrons are revolve around the nucleus. Rutherford model for an atom. Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. So Rutherford was interested that how the proton and electrons are arranged in the atom. He was not agree with the Thomson model. Okay. Rutherford experiment in that fast moving alpha particles were made to fall on a thin gold foil. So when the alpha particles are bombarded on the thin gold foil, then what happened? Some rays are totally passed, most of the rays are passed, but the few rays are come back. Okay, and from that he concluded that most of the part of the atom is what? Hollow sphere. Okay, because electron mass is very negligible, so alpha rays are easily passed, weight of the electron is negligible, as well as the alpha rays are having positive charge and electrons are having negative charge, so some attractions are there, so they easily pass. But out of 1200 or the more than that rays, one ray come back, it indicates that there is a positive charge present at the center. Okay, and because of that reason what happened? The alpha rays are having positive charge and nucleus is having also positive charge, so repulsion occur and the one ray come back. He selected a gold foil because he wanted as thin layer as possible. This gold foil was about 1000 atom thick, so he can take the gold foil. Okay, because he wanted that the thin layer as possible, and he come to know that there must be a 1000 atom. So gold foil is 1000 atom thick. So by this result he gets so many data. Alpha particles are doubly charged helium ions. Since they have a mass of 4 units, the fast moving alpha particles have a considerable amount of energy. So alpha particles are nothing but it is what? It is the helium ion and its mass is 4 units. Okay, so it can easily pass from the gold foil. It was expected alpha particle would be deflected by the subatomic particles in the gold atoms. So what was his thinking? That the most of the alpha rays come back, because he considered the J.J. Thomson model. Okay, like seeds are there, electrons are present, positively charged sphere is present, but it was not like that. Most of the rays are passed. Since the alpha particles were much heavier than the protons, he did not expect to see the large deflection. But alpha particle scattering experiment gave totally unexpected result. So by the alpha rays, when they pass from the gold foil, then most of the rays are passed because it is a hollow sphere. And second thing is that only 1 or 2 rays come back among them, because what? The center part of the atom is nucleus, it contains proton is positive charge and alpha rays are also positive charge, so it come back. Most fast moving alpha particle pass straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles. 1 out of every 1200 particles appear to rebound. Okay, dear student, in some book it is written 1200 and some book in that it is written 12,000, and in old GSB book it is written 1000. So out of 1000 particle, 1 particle come back of alpha particle. From that he concluded that the nucleus is very small. So if we compare the nucleus of atom and if we compare the nucleus size and the atom size, then the size of the atom is 10⁵ times more than the size of the nucleus. Okay, or if we put the one small cricket ball in the cricket ground, then that much size of the nucleus of the atom. Okay, Rutherford concluded from the alpha particle scattering, most of the space inside the atom is empty because most of the alpha particle pass through the gold foil without getting deflected. So initially he believed that most of the alpha rays are deflected, but the most of the alpha rays are passed through gold foil without getting deflected. Very few particles were deflected from their path, indicating that the positive charge of the atom occupy very little space. Okay, so very few particles were deflected from their path, indicating that the positive charge of the atom occupy very little space. So positively charged protons are present in the nucleus and their radius is very small. A very small fraction of alpha particles were deflected by 180 degree. Okay, so very small fraction of alpha particle were deflected by the 180 degree. Okay, indication that all positive charge, the mass of gold atom, concentrate in a very small volume within the atom. It indicates that the positively charged proton is present in the nucleus with the very small radius. So he concluded the following result: the radius of the nucleus is 10 raised to 5 times smaller than the radius of atom. So the radius of the nucleus is 10 raised to 5 times smaller than the radius of what? Atom. Nucleus is very small. If you compare, then we can consider the one cricket ground. In the center we put the cricket ball. That much size of the nucleus is present. There is a positive charge center in an atom called the nucleus. So positively charged center in the atom is called what? Nucleus. The electron revolves around the nucleus in the circular path. Okay, so the electron revolves around the nucleus in the circular path, but it was wrong. Okay, later on Niels Bohr and other scientists, they proved the wrong because it is the somewhat drawback. Okay, the path on which electron revolve around the nucleus, that is called orbit. Drawback: any particle in a circular orbit undergo acceleration, so charged particle radiate energy. So according to his theory, what Rutherford theory, that the electron move in the circular path, but whenever any particles are moving in the circular path, then it undergo the acceleration reaction and it emit the energy. So energy is continuously decrease. Particle lose energy and fall into the nucleus, so atom became a highly unstable. So according to Rutherford model, if the electrons are moving circular path, then its energy is going to decrease. Okay, it emit the energy and finally it fall in the nucleus because electrons are having negative charge and proton is having positive charge, and the atom is became a highly unstable because now electron is not present, so it is became a highly unstable, and matter is not exist. So matter is not exist, so it is impossible. And because of that, some drawback of the Rutherford model, the atomic model of Rutherford was not accepted. Okay, so today we learn about the Thomson model, we learn about the Rutherford model and its drawback. Thank you so much.